Dr. Sharma, imagine the world before X-rays. Diagnosis was so limited. How did this groundbreaking discovery happen?
It's truly a fascinating story. It all started in 1895 with Wilhelm Röntgen, a German physicist. He was experimenting with cathode rays.
Cathode rays. What exactly was he doing?
He noticed a strange phenomenon. Even when his cathode ray tube was covered, a nearby screen would glow. He called these rays X-rays because their nature was unknown. A truly accidental discovery with profound impact.
Dr. Sharma, that's a remarkable moment in medical history. But how exactly did this X-ray form? What were the conditions in Röntgen's lab?
It was quite pioneering. Röntgen used a Hittorf-Crooks tube, a type of cathode ray tube, and covered it completely with black paper. He was essentially working in a dark room. The X-rays were generated when the cathode rays hit the glass of the tube.
That's incredible. So it was pure curiosity that led to the discovery.
Exactly. And the first X-ray was taken of his wife's hand, Anna Bertha Röntgen. The image clearly showed the bones in her wedding ring, demonstrating the immense potential of this new technology. It was revolutionary.
A true medical breakthrough. And how did the practical application work then? You mentioned dark rooms.
Yes, the early X-ray procedures were quite time-consuming. Patients had to remain still for prolonged periods, sometimes up to an hour, due to the slow speed of the photographic plates. Dark rooms were essential for processing these images. It was a laborious process compared to today's quick scans.
It's incredible how far we've come. So, the formation of the X-ray was an interplay of electricity and dark matter, leading to visible results.
Precisely. A perfect example of scientific curiosity unveiling a tool that transformed medicine.
It's fascinating how they managed such precision with the early technology. Dr. Sharma, could you elaborate on the dark room process? What were the key steps in developing the X-ray?
The dark room was crucial. After the prolonged exposure, the photographic plates were taken into a completely dark environment. There, they underwent a meticulous process involving development, fixing, and washing, similar to traditional film processing.
So, it was a delicate procedure requiring precision and patience. How did they ensure the safety during this?
Safety was a constant concern, as the risks were not fully understood then. The entire process, from exposure to the final result, had to be done meticulously to get clear images and produce the final X-ray. It was a lengthy journey from that initial glow to a diagnostic tool.
It's a truly insightful process. Dr. Sharma, considering the prolonged exposure you mentioned, was there any awareness of radiation hazards and patient safety during those early days?
That's a critical point. While the groundbreaking nature of X-rays was recognized, the long-term risks were not fully understood at the time. Protective measures were not as advanced as they are today, and patient safety was a learning process as the technology evolved. So, it was a balance between pioneering medical advancement and the gradual realization of potential risks. Indeed, the early days were a period of tremendous innovation coupled with the development of safety standards that define modern radiology.